Here's what we have on the ticket for today. We're doing velocity versus time graphs. Okay, so by the end of this lesson, you'll be able to describe the motion depicted by a velocity versus time graph, create velocity versus time graph from a description of motion, and create a velocity versus time graph from a position versus time graph. All right, so recognize that this is velocity, not position versus time. Thumbs up when you have a guess. Have a conversation.
It could be both. I feel like C.
Because it's on the graph. No.
Oh, because I guess
It's not on the graph. Well, you know what?
you're not moving.
So what if you okay. You don't know this position. You don't.
But we can.
No. What? So it's easy if you're not moving. How do you come to the conclusion? Roman told you. You don't have positions on velocity.
Yeah.
You don't know every time.
Yeah.
We're seeing like a snapshot.
So 2 seconds. Yeah, Matt. The only person I know that was in the
Sorry.
Why did you
Because you wanted to take.
Because he's taking free calc and he wants the homework at free calc and this.
I feel like there's not that much homework.
Correct answer is okay. So, all right. So this is velocity versus time. This is telling you. This point here says at 2 seconds, your velocity is 0 meters per second. The way that you can think of this is think of what your speedometer is reading. It's saying 0, meaning you are not moving. Okay? If you drove to school, hopefully your speedometer right now says 0. Everybody okay with that? But does that tell you where you are parked? It does not tell you where you are parked. So you don't know your location. You do know your velocity. Does that make sense? Okay, correct answer is B. Good with that? Okay, so there's some things that velocity versus time graph tells us, and there's some things that it doesn't tell us. It does not tell us location. Okay? Thumbs up when you have a guess. Okay, I'm going to just tell you the answer. Usually this one doesn't go very well. Okay, correct answer is A. And that's all you got. Okay. You know you're moving at 2 meters a second. Most people don't have a problem with A, but this is the part that, okay. That point does not communicate how far you've moved. Okay, here's my example. If you are driving and you're getting on I-65, so you're on the entrance ramp, at some point your speedometer crosses 40 miles an hour. You okay with that? Does that mean you've moved 40 miles? What would you have to do in order to travel 40 miles? Travel at 40 miles an hour for an entire hour. Okay? The rate at which you're moving is 40 miles per hour. So if you would maintain that for an hour, you would travel 40 miles. But this doesn't tell you how far you've traveled. It just says, here's my rate. Okay? This also is your rate. Okay? In order to travel 2 meters, you would need to travel 2 meters per second for how long? A whole 1 Mississippi. Quick timeout. When I say Mississippi, like, does everybody like 1 Mississippi, 2 Mississippi? Is everybody like following? Is that still a thing in childhood? Okay. Okay. So for an entire second, this is just a point. Good with that? Okay. Something's up when you have a guess. Tell your neighbor what you think.
I knew it. Explain it. I knew it before you saw it. That is specific right there. But in the other graph, it would you can see the loss. It's over. So we're describing basically where did you make it? Did you do that?
How do we know what?
Did it?
Wait, what did you say?
Okay, what do you say? Got several for C. Okay, if this was a position versus time graph, A would be correct. But it's not. Okay, so you've got a negative value. I'm going to make up some numbers here. Let's say it's negative 1 meter per second. This is negative 2 meters per second. You're traveling at 2 meters per second in the negative direction at a constant pace. Your speedometer is on cruise control, and you're moving in the negative direction. Good? Okay. Here's a quick tour of a velocity versus time graph. All right. If you are above the x-axis, you are moving in the positive direction. If you are below the x-axis, you're moving in the negative direction. Okay. If we were to make up some values here, this is like a positive 1 meter per second, positive 2 meters per second, positive 3 meters per second. As you go up from here, you get faster. Most people have no problem with that at all. That is intuitive. Here's what is not intuitive, which I might suggest writing down. We're making up values here. Is everybody okay with this? Negative 1, negative 2, negative 3, okay? As you go down this way, your speedometer is going 1 meter a second, 2 meters, it's getting faster in the negative direction. So, as you go this way, it also gets faster. That is not intuitive. Okay, so if I could summarize that, as you go away from zero, you're getting faster. Okay with that? Okay. We will see if you're good with that here momentarily. Okay. Try this in your head. Thumbs up when you have something. So on this, I know I didn't put numbers, just relative scale to each other. Have a conversation.
If you had something like starting velocity of like say plus 3 meters per second, but it looks like he deserves like past the zero into negative 3. Would you say it's going past the negative, or it's getting slower than faster?
Slower than faster. It'd be a process. Mm-hmm. Okay, what do you say? Got some votes for D. Dangerous dinosaurs. Okay. We are in negative land. Okay. Cruise control. Okay. This one, this would be like negative 1 meter a second. This would be like negative 2 meters a second. You're going faster here. This is slower. Good. Okay. This would be true if it was a position versus time graph, but it's not. It's a velocity versus time graph. Good with that? Oh, everybody good? Talk to the neighbor.
I can't tell what's being
Okay, do the geometry movement.
We could just listen.
Can you bed? That's early. What time do you go to bed?
Okay, what do you say?
Yeah, I didn't.
Correct answer is got several C's. C. Crazy cats. Okay. Real quick, just make sure everybody's on the same page. My recommendation would be to pick points. Okay. So like here, 0 meters per second. This point here, we'll say negative 1 meter per second. This point here, negative 2 meters per second. So then tell the story. You start slow and you get faster in the negative direction. Good? Thumbs up when you have something. Tell your neighbor.
I thought it was speeding up. I thought it was me for a second. You thought speeding was like just speeding, like you were speeding up.
Yeah, that's what I said.
I was in between those two.
Correct answer is? Everybody go with A.
Yes.
Okay. Your velocity is getting away from zero. You're getting faster, and you're above the x-axis. Positive direction. Roman. Good question. Great. Hang on to that thought. Coming soon. Great question. Coming. I think next slide actually. Yep. Hold. Wait. Hold. Wait for it. Thumbs up when you got something. Hold on, moving. Hold on. Tell your neighbor.
I don't think that. Okay. Either Eric Either Eric No, it's not.
Okay. Let me just throw this out at you. For this class, velocity versus time graphs will be straight lines. Not horizontal necessarily, but lines. Okay? To do curves requires calculus. Beyond the scope of this class. Okay? So I'm limiting velocity versus time graphs to be lines, not curves. Okay? Continue to converse. Pick points, make up some values. Pick points, make up some values.
While sleeping, I want this one. You want it? I want it.
I don't know what he is. He is.
Slowing down.
All right. What do you say? Show me. A, B, C, D, E. Okay. Let's do this. Popular answer was B. So let's make up some values here. So this is positive 2 meters per second, positive 1 meter per second, 0. So you are doing what? You're slowing down, but moving in the you are moving in the positive direction. You're look, watch. So on a number line, you're moving in the positive direction and slowing down. Okay? In order to meet so not B. Go ahead and talk to your neighbor, see if you can figure it out.
You're a sheep. Don't blame me. Don't blame You had C, bro. You were gonna get a
Okay, correct answer is E. Educated elephants. Check it out. You're starting at -2 meters per second. That's pretty fast. -1 meter per second. That's getting slower. 0. Does it make sense what I'm talking about? Picking points and seeing what each point communicates and then putting it together. Okay? Roman, here you go, bud. Thumbs up when you have something. Have a conversation.
Okay, so like that last question, you're slowing down. Look at the bottom half.
I don't get like the slowing and
When
speed.
we're slowing down, but then we have to turn around because we have to then go in the positive direction. The second half. How do we know where the points are at?
You know what?
Slowing down.
So you just make up your own. So you just pick different segments out and look at.
I know his
Oh.
Just read it from left to right.
So then,
Like,
so
pick
at the bottom,
points.
we know it's moving in a negative direction, but since it's going up and that, it's gonna be.
So you have to turn around.
You're going slow, and it's negative, and you have to turn around.
So then it
Otherwise,
goes into positive.
yeah.
Correct answer is.
Yeah. Okay. I understand.
Correct answer is E. Educated elephants. Here we go. Ready? -2 meters per second. -1 meter per second. 0. This looks similar to this. Yes? Previous question. Then, here we're going 1 meter per second in the positive direction. 2 meters per second in the positive direction. So now we're speeding up in the positive direction. Good? Where do we turn around? When we cross from negative land to positive land. Roman question.
Would it be like a U in the distance percent? I'm so freaking smart.
I think I got
I
it.
think I got it. I think I've lost it.
Ever good?
Yep.
Have a conversation.
Oh, that's how I was gonna say.
Come on.
Okay.
Dude, this dude.
What do you have? What do you say? Correct answer is beautiful butterflies. Okay. Do we turn around here? Do we turn around? We're still in positive land. It's like driving and you like are coming up to like a school zone and then you speed back up after you pass through it. Good with that? All going in one direction. Yep. Ready to kick it up a notch?
No. Yes.
Given a position versus time graph, come up with a velocity versus time graph. Whoop, whoop, whoop. Keep it in your brain.
I like these. I don't know if fun. Yeah, just like you shit.
Don't blame you guys.
Wait, what do we do? No, that's stupid questions.
No, he literally smiled. He literally smiled when I asked that question. No, it was like, what an educated student. That's probably what he said.
We like nerds here. This is a good
Yeah,
way.
exactly.
I'm sorry.
Okay. Have a conversation. Tell them why you think so. Tell them why you think so.
I said not A.
I knew it was gonna happen.
Correct answer is? Correct answer is B. Beautiful butterflies. Okay? This tells us we are standing, we're maintaining the same position. So our speedometer is going to read 0. So we're standing still. Good? Next question. Let me know if you're good. Talk to your neighbor. Give them a reason.
Not teaching. I'm not trying to help. I mean, theoretically, nothing going backwards. Which is, it would be like, it would look like,
It's slowing down a bit. Well, how would it not?
it'd be like a great big hill.
No, you're not slowing down.
Slow and then, you know, really fast.
You're going the next direction.
What do you say? Correct answer is A. Okay, check it out. What on a position versus time graph tells us velocity? What on a position versus time graph tells us velocity? The slope. Okay. How would you describe the slope of this line? Is it positive or negative? Negative. Is it constant or is it changing? The constant negative slope is going to give you a constant negative value. Okay? The slope of the position versus time is the value of velocity versus time. Okay? Take it up a notch. Okay. So, keep in your head, my suggestion is take it in chunks. Okay?
I wanted to brainstorm that one. She definitely wasn't. Well, you can still brainstorm.
Wait, I thought we were supposed to keep it to ourselves.
Okay. We did? I didn't know that. I thought you might have found that.
I would see why we would rough someone up.
No. Don't talk.
This one's not a trick.
I see how it would rough someone up.
This one's easy.
With this slope,
Ooh,
No.
Don't influence me.
This is just new brainstorming. You don't get this one. This one's
Okay. I hope we get this right.
I'm gonna be really upset if I don't.
No.
That's OG.
Have a conversation.
I think it's Ed.
Why?
I read the graphics.
Nah, I want to take a look at the graphics. Make sure.
Yeah.
Look at it. Check your work.
It's speeding up in the negative direction. That's it.
Let's see. Do you want to check it? Look at the position. Do you want to check your answer? Are you?
As time goes by, it's getting further and further.
We're not in the brainstorm.
No, you're talking. You, no, you influence right now. You're influencing.
Okay, so it's C. Because he's going slower.
I bet it's
Yeah.
moving in the negative direction.
Are you actually serious?
We're in
Are you
break.
serious? No, you.
Wait, he said we could influence other people. You're lying. Wait, are we still in the brainstorming phase?
No, you're conversing. You're like
We're in the conversing phase.
you,
Hey, what if I thought it was E?
Okay, well, we can't have her.
all right. So quick vote. A, B, C, D, E. What do you got? Okay. Correct answer is C.
Almost tricked you.
Okay. All right. So here's my take it in chunks suggestion. Positive or negative slope? Negative. Okay. So that tells us we are below the x-axis. So we're okay with that on the velocity versus time graph. Okay. Steep or shallow? Steep. Fast or slow? Where is fast in the negative on a velocity versus time graph? It is away from 0. Okay. Positive or negative? Slope. Negative slope. Steep or shallow? Shallow. So you're going fast or slow? Where is slow in the negative direction on a velocity versus time graph? Near to 0, but still below the x-axis. Then you just connect the dots in a straight line. Okay, good? That's how you take it apart.
No, don't put your shoe in my face.
Okay, here we go.
Oh.
This one's just easy. Come on. It's easy.
Love the confidence.
Appreciate it.
Because it's for sure.
Yeah. You can stop influencing my opinion when it's not the influence phase.
Yo. Oh wait. Okay.
You want to influence it? We're influencing each other. I am being influenced on the brainstorming phase.
Okay. Have a conversation.
It's so Ed. It's so Ed.
Shut up.
It's so Ed. No, it's not.
Hey,
Definitely Ed.
Yeah, so
definitely.
you know
I'm trying to
it's
influence the wrong opinion.
Or the wrong answer.
How do you know that's not what I think it
And
is?
then you're gonna be influencing them, and they're gonna be saying on the wrong section.
Bro, I think it's D.
No, you do not. You do not believe that.
No, it can't be C. It's gotta be D.
What if it's a
Correct answer is B. Beautiful butterfly. Steep, positive, fast, positive. Shallow, positive, slow, positive. Connect them together. Yeah? Okay. There you go. All right. You have a worksheet due on Friday before you take off. Here tomorrow we're doing a lab with motion detectors. What you're gonna do, what I want you to do is follow these instructions. I want you to get used to this so that tomorrow we can just like lock in and rock it out. Okay. Put this in the USB port on a Chromebook. I would everybody bring your Chromebooks because Chromebooks are cheap and some of them work, some of them don't. So like have backups and backups of the backups. Okay. Follow the instructions. This works. This is a motion detector. This works like a bat or a submarine. It uses echolocation or sonar. It sends out a noise, a click, and it goes. The sound wave hits the closest thing, bounces back. It knows the speed of sound, the time it takes to go there and back, and it can calculate how far the closest thing is away from this. And it does it repeatedly, and it puts points on a position versus time graph. And then it can extrapolate that and make a velocity versus time graph. Okay. So what I want you to do in the next, we've got 5 more minutes. I want you to play around with this. Have a runway. See what it does. Okay. There's setups around the room. Just go. Chromebook, go. Just play.